Welcome everybody to Glow Your Own. It's session 3, and today we're going to be adding more control to our circuits and uploading different kinds of code and plugging in different kinds of electronic components into the breadboard to do more and better things with our LEDs rather than just plugging it in at the wall and having the light turn on. We'll control it different ways. So welcome back. As usual, we've got Sophie and Sarah with troubleshooting, and we've got Kate back from UKAEA making things and possibly helping with a bit of troubleshooting too. So lovely to have these brilliant women, scientists and engineers back in the room. Okay, I'm going to hand over to Sophie and we'll just get cracking. How about that?
Absolutely. All right, hello everybody. It's lovely to see you again. I am very much looking forward to doing this next circuit and next set of coding with you. Like Dane said, we are going to control our lights using a button this time, which is very useful because a light that is always on is really boring and not very good for the planet and everything. And I'm also just going to share this beautiful picture behind me because it's really lovely. It's a new one that's just come out from the James Webb Space Telescope that was taken with a camera that we built at the lab that I work at and at our sister lab up in Edinburgh. So we're very proud of it. It's very beautiful, isn't it? The name of it,
very beautiful.
Yeah, it's called, it's an image of NGC 346, which is not a very exciting name, but it's very beautiful and it's telling us all a lot about how stars are born. So yeah, I just wanted to share it with you because I just saw it and it was pretty and I thought you might like it. All right, so now we are going to start our coding. So the Tinkercad link is in the chat, everyone, and it's also in the email that Dane sent round just a short while ago. I'm going to share my screen and we will log in together like this. So you get to this point, it should say, welcome to Glow Your Own 2023, and then you put your nickname in. If you do have any problems with your nicknames, pop it in the chat. Sarah and Dane can find that for you. Okay, we are going to create a brand new circuit, but it's going to be based on the circuits that we have done previously. We will, because I know we've got a couple of new people, we'll do the first bit quite quickly, the bit that we've done before, and then we'll slow down a little bit when we're adding the button in, okay? Just like normal, what we're going to do is we're going to create the circuit and write the code on Tinkercad, and then we will make the real live circuit in person using our lovely little Arduinos and making it in real life. Okay, sound good to everyone? Good. All right, so we're going to create a new circuit. So you'll remember that you can click on the create button and then create circuit here. And it thinks about it. And here we go. So remember the first thing that we're going to do. Now, I asked Dane last time what the first thing we would do with a new circuit was, and he told me something which was sensible, but it wasn't the answer I was looking for. So Dane, what's the first thing we should do when we start a new piece of code or a new circuit?
The first thing we want to do is keep ourselves organized. So it's best to name it something sensible rather than dazzling Lulia, which doesn't mean anything to anybody.
Absolutely right, Dane. Thank you very much. So I'm going to call mine Glow Your Own number 3 because this is the 3rd session. Can you believe it? We're going to be halfway through at the end of this one. And then I'm going to put button on.
Absolutely much.
That's what we're going to be doing today. So I'll always know that this is what my circuit is called. Right. So first up, we want our Arduino. So we pull our Arduino out. Remember, this is our microcontroller that's going to send all of the instructions out to our code. And then our breadboard like this. So this is going to help us make the circuit without having too much soldering and stuff. So the first part of the circuit that we need to do is the bit that we've done before, a nice LED that turns on, but then once we've done that, we're going to control it using a button. Okay, so we want our LED, so we go up here to the top, grab an LED and pop it over over here, let's say. And then I'm going to connect it to our Arduino using a wire that's going to go from this leg of the LED. So you can see that I'm hovering over it, and you can see it's all connected to that leg of the LED. And it's going to go to pin number 4 on my Arduino. And then, because I like my wires to be nice and straight, I'm going to add some bits in like this, so that all of my lines are straight. You don't have to do that. I just like it to be neat. Okay. So we're going to remember that we need our circuit to be complete. So the circuit runs from the Arduino up through the wire, through this bit of the breadboard to the LED. Then we need to get back to the Arduino through a resistor. So we're going to ping up our resistor over here and put it from the other leg of the LED to the blue line with the minus sign here. And then I want to change the value of my resistor to make it not quite as strong. So I'm going to change it from 1000 ohms or 1 kilo ohm to 200 ohms. And you'll see there. Okay, so now our circuit goes from here, through the wire, up through the breadboard to the LED, down through the breadboard. Let's zoom in a bit so we can see a bit better. To the resistor, and then to this wire, to this line, sorry, on the breadboard. So one more wire to the LED going back down to the ground from here up to the wire there. And I'm going to change my wire to a brown wire because it's going to the ground, and the ground is brown. All right, so that is one complete circuit. If everyone is okay with that, then give me a thumbs up or an emoji, or make a reaction, or pop something in the chat. We've got a thumbs up, brilliant. Fantastic, more thumbs up coming. Yes. Oh, I like the little emoji with the party popper thing. That was cool. Great job, everybody. So I know we did that circuit, that bit of the circuit, quite quickly. Don't worry if this is your first time, because it's all being recorded, so we can watch it back. You can watch it back and you can pause me, which I'm sure quite a few people in real life would like to do occasionally. But you can pause and then catch up. Dane will also send around a like a worksheet that will take you through everything step by step as well. All right. Okay. Oh, sorry, Dane, what was that?
And we'll send it round, yes.
Excellent. All right. Now, this is our circuit, so that's great. We can use it to turn a light on, but we want to be able to control that light with a button, okay? And you can see the button that we're going to use is a push button here. So there are other types of buttons, but they're not in everybody's kit, so we're going to use this push button here. We're going to pull it over like this and pop it over here. So we're going to make it so that it's over the middle of our breadboard, like that. Okay. Now, we want to control our, we want to use the button to send signals to our Arduino, don't we? So I'm going to create a wire that goes from the button and to the Arduino so that we can send signals back. Okay, so I'm going to go from this leg of the Arduino here, over here, and then down to pin number 7. Okay, and because this is sending a signal back into the Arduino, I'm going to change the wire to yellow. The colors of the wire don't really matter. It's just when you've got lots and lots of wires, sometimes it's helpful to have a system. So I can see Sarah nodding, going, yes, the system is a good idea. So I always put signals that I'm sending out from the Arduino. I tend to use green wires for that, yellow wires for for sending information back to the Arduino, and brown to connect to the wire, connect to the ground. All right.
But if you're anybody like me who's colorblind, I find that really tricky. But so
Yes.
I might just choose different colors like blue, yellow, and black, maybe. So you can choose whichever color you like. And the same with your wires when you build the real circuit. Just pick colors that make sense. Absolutely.
The colors of it don't matter at all. Just can be helpful sometimes to do it that way. All right. Now, just like with our LED, we actually don't want all of the, we want to use a resistor to reduce the amount coming there. So we're going to pull this resistor out here, and we're going to pop it underneath on that same leg as our yellow wire goes from. Okay, so this resistor goes from the blue wire, which is the blue line. Sorry, words are difficult, aren't they? To the same row that in our breadboard that our wire is, and that one of the legs is on our button. Okay. All right, we've got 2 more wires that we're going to add in, but I'm going to just pause there for a second and check that everybody is up to speed. So give me a thumbs up or something when you've got the button and a wire and a resistor in there for me. Brilliant, we've got some good thumbs up already. Good job, everybody. Oh, is that a cat with heart eyes? I like it. Whatever it is. And some very cool emojis going on as well. Brilliant job, everybody. Oh, it's a hedgehog. Sorry, I'm getting distracted by the cute emojis, everybody. We're gonna move on, because otherwise I'll just look at emojis and nobody wants to watch them. Right, so we just have to do 2 more wires, like I said, and the wires that we need are because this button actually needs us to send it some more power. We've actually got a circuit that goes around from pin 7 to our button, but we're going to use and then our Arduino and then back to ground. But we're going to give it some extra power. Okay, so from the other leg of the button, we're going to have a wire from the other leg of the button down to this red line here, and typically that is the power line. And so I'm going to change my wire to red. Like Dane said, you can use whatever colors you want that work for you. Okay, so that goes to there, but then I just need to do 1 more wire that connects this red line down to the Arduino. So I'm going to zoom out a bit because I need to go to one of these power lines down here at the bottom. So I'm going to go draw a wire from that red line all the way around to the other side of the Arduino, to the pin that says 5V or 5 volts. Okay, and that will give the button the power it needs to make it work, basically. Oof. I've just spotted in the chat a really good question, because I forgot to tell you all something. I'm very sorry. Somebody, and I've already forgotten because I've just pushed the chat down, asked what value resistor we should use for the button, which is a great question, always an important one. And actually the standard one that Tinkercad uses, which is 1 kilo ohm or 1000 ohms, is about the right level. It needs a higher value of a stronger resistor for the button to work properly. So you don't have to change it here, but we will, when we're making the real one, have to use a different value of resistor. And so some of you might be able to spot that actually the values of the resistors, because they're different, if I zoom right in, you can see that these bands, you might be able to see that these bands are different. So this is red, black, brown, gold, and this is brown, black, red, gold. That's like a secret code. And if you know the code, then you can look at those colors and tell what value the resistor is. But I am really, really bad at that code, and I have to look it up every time if I need to discover what value a resistor is. Yeah. Okay. Everybody ready to write that code? Give me a thumbs up or an emoji when you're ready to start coding. Yes, fantastic. Oh, another hedgehog. I really like the hedgehog. Some thumbs up. Jolly good. More thumbs up. Oh, a pumpkin. Very appropriate. Oh, a cute little monkey. This is awesome, everyone. All right. Now we are going to write our code. So you'll all remember that to write the code, we need to press this button here. I'm just going to pull my circuit over to the far end so that hopefully you'll be able to see the circuit as well as the code here. So just like always, Tinkercad says, would you like to use this code? And we don't want to use that code. So we're just going to throw that away, move it down into the rubbish bin like that. But what we want to do is we want our code to say, Arduino, if the button is pressed, turn the light on. But if the button is not pressed, we don't want the light to be on. Okay? So we want that to happen forever. So we're going to start with our forever loop. Like that. Okay, so we've got our forever loop. And then we're going to use another one of the commands in control to essentially ask the Arduino a question. What we want to do is we want to say, Arduino, is the button pushed? And if the Arduino says, yes, it is, it should send us a message saying, okay, turn the light on. And if it says, no, the button's not been pushed, then we leave the light off. Can anybody tell me which command or which block we want to use? Can anybody make a guess? It's very like something that you might have used in Scratch before. If, very well done. If else, brilliant. If then, oh, honestly, Dane and Sarah, I think these they're all amazing. So maybe by the end of it, we're just going to be sitting drinking cups of tea, and they can all do the beginning bit. Excellent, absolutely right, everyone. We are going to use an if then else button, which is just a block, which is just down here. So I'm going to pop that inside my forever loop. Now these are used certainly in every coding language that I have ever used or studied or learned about, because it's an incredibly useful thing to do in any kind of coding. I'm just going to zoom in a little bit so we can see it a bit better. So it essentially allows us to ask the Arduino a question. And the question that we want to ask is, has the button been pushed? Now, that has the button been pushed is a type of input. That's where we're going to get the answer from. But what we want to do is do a comparison, which you might have done in maths classes. So we're going to go to the math part. Ugh. Sorry, I don't like saying math, but that's what it's called in Tinkercad. And we're going to use one of these conditions here. Okay, so if you, oh, sorry, you've all disappeared, but never mind. There you are, you're back. If you see here, you've got this triangle thing, and that is a condition. It compares two, comparison, it compares two different things. So we're going to pop that triangle thing into our if statement. Now, the standard one isn't what we want at all, because it says, is 1 less than 1? That's not what we want. We want to know if this button has been pushed. So if this button is giving a signal of 1 or yes. Often with these digital pins, 1 means yes or on. So we want to change this little arrow to an equal sign, because we want to know if it equals something. And then we're going to go to our input to find out what the reading is from this digital pin, from this pin, which on my one is pin number 7. Okay, so we're going to use read digital pin there. It's a bit too big now, isn't it? And I'm going to change that to pin number 7. Okay, so this is asking the Arduino a question. Does pin 7 equal 1 or equal on? Has that button been pushed? And if it is, we're going to have an output that says, okay, turn the LED on. And you will all remember, I am sure, that if we want to send that instruction out, that output, we go to output, and then we set pin to high. And you need to remember to change this pin number. So my LED is connected to pin 4. Set pin 4 to high. And if it's not, if the button isn't pushed, so then we put a thing in here. So we're going to set pin 4, but instead of sending it on, we're going to turn it off. So 1 means high or on, and 0 would mean off or low. Okay, is everybody ready? Remember, we are doing this quite quickly because you're amazing. But remember that we will share the instructions with you, and this is recorded, so you can just re-watch it, pause it, look back, and make sure that you get every step right. And if you do have any problems, you can pop it in the chat, and Sarah and Kate and Dane and I are all happy to help. So give me a thumbs up if you are ready to test our circuits. Oh, sorry, I've just opened the chat and found some people saying, talking about Boolean operators, which is fantastic. Oof, I like the frogs. Excellent. So give me a thumbs up or an emoji, something like that. Oh, someone shared their code. Brilliant. Oh, a ghost. It is getting close to Halloween. It's not
quite
close
Christmas.
No, it's not close to Christmas yet, everyone. We're going to do Halloween first. All right. Good job, everyone. Oh, the bunny's cute. All right, so now we are going to test if it works. This is the moment of truth. So remember, we're going to start our simulation. Now, if this works, my button isn't pushed, so nothing should happen. So let's start the simulation. Everyone start your simulation too. Okay, and nothing's happened, which is good because nothing was supposed to happen. Our button isn't pressed. Now on Tinkercad, when you want to simulate your button being pressed, all you need to do is hover over it with your mouse. You can see my mouse on the screen, can't you? Yeah, and then click it. Click and hold, and that means the button is pressed. And you can see that my light came on, which is awesome. And then I've unclicked, and my light is turned off, and I'm clicking, and my button is on, and I'm unclicking, and my button is off. I think you can tell. So if you look really closely, if I zoom right in, you can see when the button isn't pressed, you can see this little gray bit underneath the button. And then when it has been pressed, that disappears because the button's gone down. So you can always tell if that bit's working. And I'm not just pretending that I'm pressing the button. Brilliant. So give us a thumbs up if you have got a light that turns on and off when your button is pressed. Sarah does. Fantastic.
Me too. Yay.
Brill. We've got lots of thumbs up. A frog. Excellent. It's a very friendly little frog. Oh, and a puppy. It's very cool. I completely agree. fantastic. And a squirrel. Oh, good job, everybody. If it's not quite working yet, that's absolutely fine. If it isn't working, but you think it is, pop something in the chat, and with your Tinkercad nickname if it's not in your name, and then we can have a look and give you some help to see if we can figure out together why it isn't working. Awesome. So well done, everybody. If your light is dim, it might well be that this resistor here that's connected to the LED is a bit too strong, a bit too powerful. So make sure that this is in ohms, not kilo ohms. Kilo ohms is just 1,000 ohms, and around 200 or so. All right, so now we're going to make our circuit in real life. So I think lots of you have your oh, sorry, I'm going to stop the simulation and move the code away so we can see the circuit again. There you go. Oh, there, that's better, isn't it? So what we need to do is we need to take our breadboard, take our Arduino and our breadboard and the different components and start to make them. Okay, I'm going to start my video. There we go. So you can see I've got my Arduino ready. I'm going to pop it like this, just like it is on the Tinkercad picture. And I've got my breadboard, which is going to go here, like that. And you can see, oh, I'm going to show you, look, here's my laptop. And this is why I'm getting left and right, because I've written left and right on Post-it notes, so I can tell which way around it is. Okay, so we're going to make our circuit with the LEDs like we did before. So this is the LED. And remember, one leg is shorter than the other. Actually, if I pop it down, you might be able to see it a bit better, but not if it rolls so that it's that way. So you can see that one leg is shorter than the other, and the shorter one should be next to the resistor. Okay, so I'm going to pop this in my circuit like this. Sometimes you need to be quite firm with it to go there. And then I'm going to find a wire and I'm going to connect it to pin number 4. Is that pin number 4? There we go. Like that. Pin number 4, and then to my wire. To this breadboard next to the LED on the right-hand side. So there we go. Then I'm going to get my resistor. Now we're going to remember we're using 2 different values of resistors today. It depends on what kit you've got, but if you've got a kit like mine, your resistors come in things like this, and on the edge of them it's written what value it is, so 1 kilo ohm. Okay, if you can't see that, pick one, and if it doesn't work, we'll pick another one. Yeah, all right, but I've got one that is like a few hundred ohms, 300 ohms in my case, and I'm going to connect that to one side of my resistor. And sorry, my breadboard is spinning around a bit. There we go. Oh no, that didn't work very well. Like that. And then connect it to the blue line. Oh, sorry, my breadboard is spinning around like anything. There you go. So you can see there now. So my resistor, now it is a bit hard to see because the resistor doesn't show up very well against the breadboard. You can see it's connected to the blue line and then up to the left side of my LED, just like in the circuit diagram that we did on Tinkercad. Okay, and then the final bit of that circuit I don't have any brown wires, so I'm going to use an orange wire. And I'm going to go from this blue line here to a button that says GND on the Arduino over here. Now, you can put it right next to yours. So you can see that goes to one that says GND, like that. Okay, so that's one complete circuit done. How are we doing, everyone? Have you got your, is that circuit done? Give me a thumbs up. And if you would like me to pause for a minute and so we can look at the circuit on Tinkercad again, then we can do that as well. We've got some thumbs up, brilliant. Good job trying, everyone. It's really quite fiddly when you're making these sometimes. And the key is just to be patient and to persevere. That's a really important thing with all of the code. I've never made a code for science or anything that has worked first time. I've always had to go back to it and change it and tweak it and then curse it and then come back to it and then change it and then have a big party because it finally works in the end. All right, we've got lots of smiley happy faces, which is fantastic. So now we're going to do the second circuit, which is that button circuit. Okay. Oh, the pig is cute. Now I'm going to show you the button. I've just popped it down there. Focus, little Arduino cam. You can do it. It doesn't want to focus on it. So it's a little black square with a black circle in a little silver square with a black circle in, my one is, but sometimes your buttons are different colors. So Sarah's got a big green button, quite a cute one actually. I like it. And so your one might look different, but it will have these 4 little legs at the bottom. Oh, that's not helpful, is it? There you go. You can see it's 4 little legs. Focus, Arduino cam. You can do it. There you go. All right. We are going to put those over the middle of our Arduino, of our breadboard, sorry, like this. This can be a bit fiddly, so I might have to put the camera down for a second to do it so I can hold my breadboard. In fact, I'm going to have to do that, everyone. Sorry. 2 seconds.
So you might notice as well that it's not, the 4 little legs aren't quite square. So it's the 4 legs are in a slightly rectangular arrangement. So it might be that so what we're doing is we're crossing the breadboard boundary. And so you just need to make sure that your 4 little legs will fit in right. And so you might just need to rotate it around by 90 degrees to make it go over the breadboard boundary. If you remember last time, we showed you what the inside of the breadboard looks like with its various bars. And so that little recess in the middle isn't connected to the other side. So the little horizontal bars, if you remember, a bit like on Tinkercad, when you hover over the dots in Tinkercad, you'll see a little kind of series of connected circles. And so those bars on the breadboard in real life are the same as those little connected circles on the breadboard on Tinkercad. So that's how the breadboard is put together.
It says, well, my button is slightly larger than Sophie's. So instead of going in those same holes, mine are the next one's out, but it still works fine. It's just a slightly different shape. Just got to be quite careful to get them into some holes where it fits.
It just depends on which kind of button that you've got, but they all work the same. All right. There we go. So we've got our button in. And now we're going to do the wires. And so we're just doing the same as we did in Tinkercad. So I'm going to put a wire, nice yellow wire, for me from one of my wires to pin 7 on my Arduino. So let's focus in here. and put it in there. And then push it in. All right, so you can see that that is on the same row as one of the legs of my button. And then I'm going to put it into pin number 7. Oh, that can be a bit fiddly, but there you go. So that is on pin number 7. Focus, Arduino cam. Yeah, there you go. So you've got that one wire done. Brilliant. I'll just move it over here for a second so that we can see the different bits and pieces. And now I'm going to put the resistor in. Now remember, this is a different value of resistor. We're going to use 1 kilo ohm. So it might just say 1K. That's what mine says, 1K, like that. But it should be a stronger resistor. So I'm going to grab one of those. I should have picked one out earlier, but I didn't. And that's going to go from the same row of my breadboard that the yellow wire and the button leg are. I'm just going to pause for a second while Arduino Cam tries to focus on it. Come on, you can do it. There you go. And that goes down there. Like that. And then it's going to go to the blue line. Oh. Sorry, I've just realized that whenever I try and do this, I stick my tongue out like a crazy person because I'm concentrating so hard. So do forgive me, everybody. I'm not sticking my tongue out to any of you. So that's going to go in there like that. And if I just change the angle a bit, you can see that that resistor goes from the yellow wire row to the blue line row. Okay. All right, just 2 more wires to go and then we're done. How's everybody doing? Give me a thumbs up if you're doing okay. Brilliant. Sarah's there.
Coming along well.
Right,
Good.
excellent. So yeah, give me a thumbs up or Brill. Got some great thumbs up from everybody. And some in the chat. Good job, everyone. Like we always say, don't worry if this is going a bit fast because we're recording it. You can watch it back, you can pause it. And we've also got the troubleshooting session at the end. So we can give a hand with that then too. All right, so 2 more wires, everyone. We're going to use some red wires to give this Arduino some power. All right, so you remember that the first red wire goes from the one of the legs of the button. So over here, let's pop that in there, like that. So you can see that it's on that same column, and then it goes to the red line on the breadboard. Sorry, my hand was completely in the way then. There you go. So you can see it goes to that red line with a plus on it. And then we're going to go from the red line to the 5V pin on the Arduino. So that wire goes from that red line. Plug that in there. And then the 5V is over here. Oh, sorry, I think I'm going to have to switch hands. I'm going to try anyway. And put that in. Oh. Like that. I need a camera person to be holding the Arduino cam while I do that. But you can see, so sorry if you didn't quite spot that. You can see that it is connected to the one that says 5V. I'm just checking it is connected to the one that says 5V. Yes, it is. There you go. All right, and now we've got our beautiful circuit. this is a really fiddly bit. Kate is quite right. It's always the bits that I get wrong, and I put them in just one too far, the wrong way round or something like that. But that's okay. You just have to be patient, trace your circuits, and make sure that they go in exactly the same places that you've got on your Tinkercad circuit. If it's not working, do pop something in the chat and we'll do our best to help you. So if you have a question about where something should go, I'm just going to share my screen again so that we can see where everything should go on this. And like I said, do watch it back and pause me so that you do one step at a time. Okay, all right. We are nearly ready to send our code to our real Arduino and to hopefully make it work. Sorry, everyone. So I'm going to turn Arduino cam on and switch. No, I'm going to turn Arduino cam off. That was a complete lie. Like that, so that we can do the circuit in real life. Now, do you remember that we're working with all of these small little components? So make sure, just have a quick look around, that there's nothing left on the floor where anyone could pick it up, or any pets or any babies or anything like that. Make sure it's all on the table and make sure you tidy it all the way at the end. Okay, so now we're going to connect our Arduino to our computer and then send it in. So we connect our Arduino to the computer using the USB cable. And when it works, I'm going to just turn Arduino cam on for a second. Let me see. Have we got Arduino cam? Go. So
let's stop sharing Tinkercad for a second.
Sorry. Thank you.
Sorry.
There you go. All right, so you can see that my Arduino is on. And because my Arduino remembers the instructions I gave it last week, my light is on as well, which is good, but it's very, very bright. Sorry, everyone, the green light is clearly very bright. But you can tell it's connected properly because there are the little lights on the Arduino which are on. So that means it is getting power from the computer. And it's connected via this cable, the silver bit, up into my laptop there. It's this wire here. Okay, so let's share my screen again and we will send the code in real life to the Arduino. Right, so firstly, let's look at the code again. And then we want to change this bit on the left-hand side from blocks to blocks plus text. Don't change it just to text because then it can be hard to change it back. So if you change it to blocks plus text, you'll see it both in the nice blocks that we use and in this other language, which is called C++, because we're really good at naming things, and C++ is obviously a great name for a code. For a coding language, and we want to highlight all of it and then copy. So Control C, once it's all highlighted, is the easiest way to do that. Control C. Then we're going to go to the Duino.app. So open a new tab and type Duino.app, and I'll just pop that in the chat for you. As well, just to make it easier for you to find, and you can just click on it. That's if I can find the chat button, which right now I can't. There we go. But Sarah's already on it, so I don't need to do it. Thank you, Sarah, you're brilliant. Okay, so once we're in this Duino app, this is what we're going to use to send our code. This works best if you're using the Chrome browser. There are some other methods if it doesn't work, but this is the easiest one to use Chrome. So we want to code. The answer is we always want to code. So we press code, and then we're going to create a brand new project. And I'm going to call it the same name as I called it in Tinkercad, which was GYO3 button. So that's easy to do. So we're going to call it that. Do make sure you give it a name, otherwise Duino gets upset with you. And then press create. All right, now, just like Tinkercad, it says, oh, would you like to use this code? I've written some code for you, but we don't want to use that code. So you highlight it all, so you can just click in and do Control A and then delete it all. And we want to paste the code that we have written into the Duino app. So we do Control V because we've already copied it in. But then I remember that I copied the thing. So you go back because I'm not very smart. And here we go. Here is our code again. Let's copy all of this. Control C. And there you can see here is the code, because I think somebody just wanted to have another quick look at the code. But Sarah's on it too. And we're going to paste that into here. So now we've got our code in this bit, nearly ready to send it in. So we're going to go down here to the bottom on the right-hand side and click Select Device. And then this other little pop-up comes out. You can all see the little pop-up. Yeah. And it says the Duino app wants to connect to a serial port. So it wants to connect to your Arduino. And we want to go to the USB serial device. Now, different computers call this different things. Sometimes it will say Arduino. Sometimes it will have like COM4 or a different number here. I can't find any rhyme or reason in it, but pick the one that says USB serial device or Arduino. And if you're not sure, put all the options in the chat, and we'll that you're being given in the chat, and we'll see which one looks the best. And we can always do that in the troubleshooting as well. So once you've clicked on it, you press connect. And then you'll see down here, instead of it says serial selected. So something has been selected. All right. Now the last step, hopefully apart from bug fixing, is to go up here to the top on the right-hand side, where there are 3 different little buttons. You can do check and compile, you can do compile and upload, and you can do serial. Next week, we're going to play with the serial monitor, which I always like because it helps you find bugs, and I'm really good at bugs, making bugs. But what we want is this one in the middle that looks like a play button that says compile and upload. And compile is just turning it into language that the Arduino understands, and upload means sending it. So we click that button and you cross your fingers because that always helps. And you see it's compiling, that's thinking about it. It's uploading, it's sending it, and it's 100% done.
Yay!
Yeah. And I realized, I'm very sorry, I should have turned on Arduino cam for a second. So I'm just going to stop my share for a second so that we can see if it works and if I've wired it up right. I might well not have done so because this is me and I'm not very good at it. So you can see that it has, my light is now turned off, which is what it should be because the button's not pressed. So the light should be turned off. Now I'm going to press the button and see if my light turns on. Everybody cross your fingers. And it doesn't work. You see, it happens all the time to me.
Mine isn't working either. It's very sad.
Oh, no.
Oh, well, I got mine working.
Well, Dane wins the prize for doing it quickly, for doing it right. Good job, Dane. All right, so.
Which is rare.
No.
So we're going to fix yours. We're going to fix yours afterwards.
Well, we've got lots of people that are working. You are all amazing. Well done, everybody.
Excellent.
If it doesn't work, don't worry. Like I said, mine's not working either. So what we're going to do, just in case, we'll fix it in the troubleshooting. What the thing to do is to check all of your connections, because what's likely happened is that I've maybe put one of my wires in not quite the right place, and so it's not going around in a complete circuit, or I haven't pushed the resistor in all the way properly, which is really easy to do. So don't worry, what you need to do is just check and trace it, and if it's working on the Tinkercad, make sure that your circuit looks exactly like it does on Tinkercad. Okay, I will hand over to I'll hand back to Dane to wrap up the recorded part, and then we can fix it. Okay, so Dane.
Well, I'm sorry that yours hasn't worked quite as it should, Sophie, but loads of people got theirs working, and I'm really happy. I'm going to show you mine, because I was really happy that I got mine to work first time. And I have to say, I was a bit lazy putting in my LEDs, because I left them in from last time. And so what I did is I slipped in 2 more extra lines of code by just setting 2 different pins to go high when I press the button. So I've switched it like that, and if I press go, oh no, what? Now it's not working. Curses. Let's see. I was also trying to do something different. So here we go. Look. So what I've done, so the other thing that's quite fun that you can play with, so obviously we're uploading our code to the Arduino by plugging it into a laptop. But what I've then done is I've unplugged it from the laptop and I've plugged it into a USB battery. So all this is now doing is attached to a battery. And so if I press the button, so I've got 2 LEDs, and I put 2 little LEDs in my Tinkercad and uploaded that code. So if I press the button, both of them go on, which is great. And that's the extra fun bit, I think, is that you can just plug it into a battery, and it's the actual Arduino that's doing all the thinking for you. It's nothing to do with the computer when you get to this stage. The computer's just providing power. So you can have a little play with that. But I think everyone's done such a great job. A couple of little things that we need to fix in the troubleshooting, but we'll deal with that later. And we're looking forward to seeing you next time. But meanwhile, from Sophie, Kate, Sarah, and me, well done and goodbye.
Well done, everyone.